How do you prove properties of the Fibonacci sequence? Have you ever wondered how mathematicians prove the fascinating properties of the Fibonacci sequence? This sequence is not just a series of numbers. It holds many secrets and patterns. Let's break down how these properties are established. The Fibonacci sequence starts with 0 and 1. Each number in the sequence is the sum of the two preceding numbers. So it goes 0, 1, 1, 2, 3, 5, 8, and so on. This simple rule leads to many interesting properties. One common method for proving properties is mathematical induction. This technique involves two main steps. First, you check a base case, usually the first few numbers in the sequence. Then you assume the property is true for a number n and show it holds for n plus 1. For example, if you want to prove that the sum of the first n Fibonacci numbers equals fn plus 2, 1, you start with the base case and then use the recurrence relation to extend your proof. Another approach is using recurrence relations. Many identities related to Fibonacci numbers can be proved by showing that both sides of an equation satisfy the same recurrence relation. If both sides follow the same pattern and match at the beginning, you have a valid proof. There's also a fascinating closed-form expression known as Binet's formula. This formula allows you to calculate Fibonacci numbers directly without recursion. It involves the golden ratio, which is approximately 1.618. The formula states that fn equals the difference of two terms raised to the power of n divided by the square root of 5. Proving this formula requires solving a characteristic equation and confirming initial conditions. Algebraic manipulation is another useful tool. Many properties, such as relationships between sums of squares of Fibonacci numbers, can be proved through algebraic methods. For instance, the identity that states the sum of the squares of the first n Fibonacci numbers equals the product of the nth and n plus 1. Th Fibonacci numbers can be shown using induction and the definition of the sequence. The Fibonacci sequence is not just a mathematical curiosity. It appears in nature, art, and even computer science. Understanding its properties helps us see how these numbers relate to growth patterns and efficient algorithms. In summary, proving properties of the Fibonacci sequence involves checking base cases, using recurrence relations, and applying algebraic techniques. Each method reveals the beauty and connections within this remarkable sequence of numbers.